good morning, good students. It's JD here. Today we are going to take a closer look at how we differentiate functions of the form f of x to the power of n. Right? How do we differentiate functions of this form? What is y prime? Y prime here, what is our dy dx? Right? How do we differentiate functions of the form f of x to the power of n? Okay, to differentiate functions of this form, what you need to do, take this n, write down this power first, right? And then multiply by the derivative of f of x. So remember, f of x can be any function. It can be an exponential function, a trigonometric function, a polynomial function, etc. Right? So multiply by the derivative of f of x. And then write again that function which is f of x, but this time around subtract 1 from the power. So yes, that's how we differentiate functions of the form y is equivalent to f of x to the power of n. Like I said, bring down the power, multiply by the derivative of f of x, and now rewrite f of x but subtract 1 from the power. Okay, let me reinforce this concept further by means of an example. Example number one. So on example number one, let's take for example, we've got y is equivalent to ax plus b to the power of n, right? In this case, our ax plus b is basically a polynomial function where a and b are constants. So for us to find dy dx in this case, we are going to bring down the power, which is n, and then we are going to multiply by the derivative of ax plus b, and then after that we are going to rewrite ax plus b, then we subtract 1 from the power. So by the end of the day, it's going to be n times what is the derivative of ax plus b. Straight away we get a, then we multiply by ax plus b to the power of n minus 1. If you rewrite this, n times a, we basically get na times ax plus b to the power of n minus 1. We still get ax plus b to the power of n minus 1. Yes, that's how we differentiate uh, ax plus b to the power of n. Okay, let me reinforce this concept further by means of another example. Let's call this example number two. On this example, we want to see how, let's say we've got y is equivalent to the square root of 3 minus 2x. How are we going to differentiate the square root of 3 minus 2x with respect to x? Okay, so this is, so before we say dy dx, let's make sure that we rewrite our y value in the form y, in the standard form, in the form f of x to the power of n. So in this case, we are going to write this as 3 minus 2x. So this is going to be 3 minus 2x to the power of half. But remember, if I say the square root of a, this is basically the same as a to the power of half. So the square root of 3 minus 2x is the same as 3 minus 2x to the power of half. Okay, so now as we see here, we have a certain function which is 3 minus 2x. And this certain function is raised to the power of 1 over 2, power of half, right? Exactly, it is a function of the form y is equivalent to f of x to the power of n. And how do we find, or how do we calculate dy dx in this case? Like I said, bring down the power, right? Multiply by the derivative of what is inside the bracket here. So what is the derivative of 3 minus 2x, right? As we differentiate polynomial functions, remember the derivative of x to the power of n is the same as nx to the power of n minus 1. So we bring down the power, then you subtract 1 from the power. So in this case, the derivative of 3 straight away will give us 0. Like I said, the derivative of a constant is 0. And the derivative of minus 2x, again using this rule, straight away we will get minus 2. So here we will get minus 2. So we rewrite that function again, which is 3 minus 2x to the power of 1 over 2 minus 1. So you subtract 1 from the power. Okay, so what is the next move? The next move, we have to simplify this. So what is 1 over 2 times minus 2? So we get minus 1 times 3 minus 2x to the power of what is 1 over 2 minus 1? We get minus 1 over 2. So yes, this is our final answer. You can also try to rewrite it in another form to say this is the same as minus 1 over the square root of 3 minus 2x. So yes, this is the result that we get if we differentiate the square root of 3 minus 2x with respect to x. You might need another example, and yes, let me provide another example. Example number 3. What if we have got y is equivalent to y is equivalent to sine of 3x to the power of half. Let's say that y is equivalent to the square root of sine 3x. How do we um, differentiate this? I'm leaving this for you to do as an exercise. Number 4, what if we want to find the derivative of y is equivalent to ln of 3 um, of 3x everything to the power of 2. How do we differentiate a function of this form? So remember, we've got ln of 3x, that's our function, and raised to the power of 2. So for us to do this, like I said, for us to find y prime, which is our dy dx, or what we need to do, we bring down the power. After bringing down the power, you multiply by the derivative of ln of 3x. What is the derivative of ln of 3x? Remember, we need to know that the derivative of ln of a certain function. Let's say you want to differentiate ln of a certain function. Or what you need to do is to find the derivative of f of x, then you divide by f of x. So for you to differentiate ln of 3x, you need to find the derivative of 3x first, which gives you 3, then you divide by 3x. So yes, this is the derivative of ln of 3x. 3 over 3x. Which rule have we applied here? We have applied this rule to differentiate ln of 3x. So yes, we get 3 over 3x. Again, according to this one, let's keep again ln of 3x, but this time around, let's subtract 1 from the power. So that will be to the power of 1. So if we simplify this, our y prime, that's our dy dx. So 2 times 3 over 3x, remember 3 over 3x will give us 1 over x times 2, we get 2 over x. So it's going to be 2 over x times ln of 3x. This is our final solution. Okay, okay. So I'm leaving question number 3 for you guys to do as an exercise. This was so much interesting. Awesome. Awesome. Awesome.